So next we move on to fats, lipids, oils. And with fats and oils, as all of you experience, some of the properties, they're greasy, they're slippery, they don't dissolve in water. You know this when you have a level, when you mix oil and water, you can see two separate levels. And in terms of food, the butter, cheese, also, vegetable oils as well, guacamole, um, corn, olives, etc. So there's many types of fats and oils, and we'll dive a little bit into telling the differences. And then we have molecules, they're both triglycerides. And what is a triglyceride? They contain 3 ester functional groups, and we'll show more in detail later. But an ester group is when you have a carbon with a double bond O, and then next to the carbon you have another oxygen. And these R groups just designate other carbon chains. So here is a nice chart of how to separate out the lipids. We have here the triglycerides, which can be broken down into fats and oils, and we have beeswax and steroids as another form of other lipids. We have the fats or triglycerides. Again, that's composed of 3 esters and 1 alcohol glycerol, which we'll show later. Within these fats and oils, we have, you probably heard the term saturated, and saturated fats, they're solid at room temperature. They have no carbon double bonds, so they're harder to break down. These are like animal products, dairy products, and meats. And then you have unsaturated, which are liquid at room temperature. And they have at least 1 double bond, and the double bond allows it to be reactive, and it can be broken down easily by enzymes in your body. So these are things like nuts and plant oils and avocados, etc. So a fatty acid, it has 2 main components, a long hydrocarbon chain. So here is the long hydrocarbon chain, which is just carbons connected together, and they're usually about 12 to 24 carbons in length. And you have this at the tail here, you have this carboxylic acid, and this is different than an ester because the carboxylic acid is composed of a C double bond O, C OH. C double bond O, COR, or carbon, would be an ester. But here it's a carboxylic acid. And as I mentioned earlier, we have the saturated versus unsaturated fat. And the unsaturated fat has at least 1 double bond. So here's a double bond. These points here are carbons. So we have carbon here and a carbon here with a double bond. Versus a saturated, which has no double bonds. They're all single bonds. So as I said, the double bonds make it more reactive, and hence they can be broken down more easily in the body. We talked about oils and fats. Here are some foods and its components. I forgot to mention that triglycerides, they're the most common types of fat, and they store energy in the body. You don't want too high levels. It's not good for you. And if you do have too high of a triglycerides, you try to lower it through exercise, your sugar intake, your alcohol intake. And here's just a table of some of the saturated and unsaturated fats. So here you could say, based on what we spoke about, the more healthy oils are here that are saturated, which have the double bonds, like coconut oil, palm kernel oil, the ones in blue, higher levels of saturated, versus the unsaturated ones here, like safflower, canola are more or are less healthy for you. And something else you've probably heard of is trans fats. And trans fats means that these trans fats are formed first by a process called hydrogenation, which we will not get too much into much detail. But here we have their type of a trans fat is a type of unsaturated fats because of the double bond. So the double bond here, if we look at the double bond, the H's, the hydrogens, are opposite to each other. They are trans to each other. Versus in this case, the H's are cis to each other. They're on the same side of the double bond. So again, I should mention the double bond here. This is a carbon with another carbon with a double bond in between them. And trans fats are not good for you. Things such as French fries have it. The FDA has labeled these very unhealthy. And why are they unhealthy versus the cis? Well, it's because of their shape. The natural shape for the cis, when they're on the same side, they can be easily disrupted and broken down much easier than when they are trans to each other. So again, these can be broken down easier by your bodies in your enzyme. In terms of trans fats versus cis versus saturated versus unsaturated, and we'll move on to carbohydrates next.